Let's have a look at redox reactions. Redox reactions involve the transfer of electrons from one atom to another. So an atom that loses an electron is oxidized, and a way to remember this is with the acronym OIL, and OIL stands for oxidation is loss. On the other hand, an atom that gains an electron is reduced, and we remember this from the acronym REG, reduction is gain in electrons. So let's have a look at our sulfur atom. Sulfur, if it's ionized to 2-, we say that it's reduced, it's gained electrons. A sodium atom that loses an electron is oxidized. We can also get this in ions. So if we've got Fe3+, if it loses an electron to become Fe2+, we say that the ion is reduced. A nice way to remember oxidation and reduction is to draw a number line. The more positive we become, or the electrons that we lose, is the process of oxidation. On the other hand, the more negative the atom becomes, or the more electrons it gains, the more that atom is reduced. Oxidation is always paired with reduction, hence we get the term redox reaction. So let's look at an example from an equation. If we have our sodium in its solid form, its elemental form, combining with chlorine in its elemental form, we form sodium chloride. Let's break this down into a diagram and see what happens. The sodium is giving up an electron to the chlorine. We get 2 of them to break that bond between the chlorine so that we're left with sodium ions and chloride ions. In this case, the sodium acts as a reducing agent because it reduces the chlorine by donating electrons. On the other hand, the chlorine acts as an oxidizing agent because it takes those electrons away from the sodium. In the reaction between magnesium and oxygen to form magnesium oxide, the magnesium goes from a state of 0 to a +2 state because it gives up 2 electrons. Therefore, the magnesium is oxidized. On the other hand, the oxygen goes from a 0 state to a -2 state, so that we say that the oxygen is reduced. Magnesium is oxidized, therefore is the reducing agent, and the oxygen is reduced and is therefore the oxidizing agent. In terms of redox reactions, we need to track where the electrons are transferred to. Each atom needs to be assigned an electrical charge, which is easy for ionic molecules, but not so easy for covalent molecules. So we need to assign what's called an oxidation state that is assigned regardless of the bond type, whether it's ionic or covalent. So how do we predict what oxidation state an atom is in? Well, we have a few rules that we can follow. First of all, if we have an element or a neutral molecule, we say that the oxidation state is 0, and there are no exceptions to this. So an example might be sodium in its elemental form. Its oxidation state will be 0. We can also have a look at nitrogen in its elemental form. The nitrogen is said to be in an oxidation state of 0 as well. If we look at monatomic and polyatomic ions, the state varies according to the charge on that ion. So if we've got cobalt in a 2+ form, we say that the oxidation state is +2. If we've got a carbonate polyatom, which has a charge of -2 on it, we say that the carbonate is in an oxidation state of -2. And then if we shift back, we can actually work out the oxidation states on the carbon and the oxygen as well. Fluorine always has an oxidation state of -1. There are no exceptions to it. So if we look at a compound involving fluorine, sodium fluoride, fluorine will always be in the -1 oxidation state. If we look at hydrogen, hydrogen always exists in a +1 state, except in metal hydride compounds. So as an example, our hydrochloric acid, Hydrogen exists in the +1 oxidation state. Oxygen always exists in a -2 state, except in peroxides. So an example would be H2O2, where the oxygen exists in a -1 oxidation state. Or when it's bonded to fluorine, and if we remember that fluorine is always -1, we find that the oxygen must be in a +2 state. So in our water molecule, oxygen would exist in a -2 oxidation state. To go with our rules, we also have an extra set of guidelines. So for group 1 elements, they exist in a +1 oxidation state. So our sodium chloride, our sodium will be a +1 oxidation state. Group 2 elements exist in a +2 state. So our magnesium oxide, our magnesium will exist as a +2. +3 atoms, we have aluminium, scandium and yttrium. The other group, or the other elements in those groups, don't necessarily exist as +3. But these three do, and we get aluminium nitride. The aluminium will exist as a +3 oxidation state. Group 15, in general, exists as -3 oxidation states. So we can get our magnesium nitride. The nitrogen will exist as a -3. Now that's not always the case, but in general, that's what occurs. Group 16 generally exists as a -2. So we can get our water and our oxygen exists as a -2, as we said before. Our group 17 exists generally as a -1. So if we've got lithium bromide, our bromide will exist as a -1.